Hello and welcome to your this lecture video, which covers how to do regression in Excel. And so regression in management accounting can be especially useful when you're dealing with cost estimation for a mixed cost. So remember, a mixed cost has some fixed and variable components, and so what we need to do in order to estimate a mixed cost for a different level of production or a different level of activity is we have to parse the mixed cost into its fixed and variable components. And that's what regression can help us do. It can help us to take an overall mixed cost and then figure out of that mixed cost how much is variable and how much is fixed, okay? And so if you think back to some of your statistics classes, what does regression do? Regression finds the line that best fits the data. And by finding the line that best fits the data, what it's really doing is it's finding the line that minimizes the sum of the squared errors, okay? And what I mean by an error is the data point versus the line that regression is trying to find that best fits the data. The data point is not exactly on the line, so that's the error. And so it finds the line that best fits the data by minimizing the sum of the squared errors. It's a little bit overkill for what you need to know for how to just do it in Excel, but what it can do, what regression is going to give us is it gives us the slope of the line and it gives us the intercept. Now remember, the slope of the line is going to be our variable cost per unit. And then the intercept is our fixed cost. So really what we're trying to do is we take these mixed costs, which in this example is our overhead cost. We have units, and we have total overhead, and overhead would be an example of a mixed cost. And what we're trying to do is take this overhead cost and figure out of this overhead cost how much is fixed, how much is variable. And so what we can do is we can use regression to estimate our variable cost per unit and then figure out of that, which is the total variable cost, and then back in to figure out our fixed cost. Okay, so why don't we go ahead and start it? So we're going to come over here, and this file, it's called regression example 2.xlsx, is posted on Canvas. It is located under modules, so do not go to files, go to modules, and you'll find it there. Okay, so if we come over here, and here's our solution, and this is what we eventually want to get to, is we have our variable cost per unit, we have our fixed cost. Okay, so you can come over here, we're going to say our VC per unit. Now you may have done regression in Excel in some prior classes, some stats classes, where you actually brought in the data analysis tool pack for Excel. We don't really need to do that. Actually, what there is there's a function in Excel called equals slope. So I just come over here and I say equals slope like this, and I say my known y's. What are my known y's? It's my overhead, right? Because my y is my dependent variable, which is my overhead. My x's are my independent variable, which are my units. Let's say my known y's. Then my known x's are my units. Come over here. That's my slope. And then you can see is we can check it right over there. Okay? And then what I can do is I can format it as $1, 98.83 cents. Okay? 90.83 cents. Now I can say my fixed costs. Okay? So I'll come over here and I'm going to use a different function. It's called intercept. Okay? My known y's, my known x's. That's my intercept. Okay? And I'll format currency. Okay? And then we can say our coefficient of correlation, which is our correlation. So we can just come over here. And we can just go Pearson. Now what correlation does is with our correlation there is no dependent independent variable. So you can specify this one first or this one first or this one first or this one first. It doesn't matter. It's just saying how well do two variables move together. Do they move up together, or as one variable moves up, the other one moves down? How closely related are these two variables? Okay. So over here, say that. And my array 2, and that's in express correlation as a percentage. And then I can say r squared, and the function for that is RSQ. Now this one I do have to specify my dependent first and then my independent. My dependent is my overhead, but then my known x's is my independent. And again, this one is also expressed as a percentage. R squared, just like correlation, goes from 0 to 100. The higher the r squared, what the r squared is basically telling you is how much variance in the dependent variable, in this case overhead, is explained by your independent variable, which is our units. Okay, how much of that variance is explained, and so the higher the r squared, the better the independent variable is at explaining and predicting the dependent variable. Okay, so that's what that means. All right. So now what we can do, and that's a little bit overkill for what we need to do in terms of determining the correlation and then the r squared in order to do cost estimation. Although it is something you'd want to look at, because if you have a low r squared, what that's saying is that really there's not much of a relationship between your dependent variable and your independent variable, and so really what you're saying is that your units, would not be much of a cost driver for your overhead cost if this were a low r squared. But we can see that the r squared is pretty high, okay? And so in that case what we can surmise is that units is a good explanatory variable. It probably is a cost driver for our total overhead cost, okay? So now what we can do is we can say we want to predict total overhead cost at 3,500 units. So I'll come back over here. And by the way, when I'm clicking over on this file, I'll show you that it's our regression example 2 completed. This is the solution file, and that's also posted up on Canvas under modules, okay? But I'll come back over to my file. So I can come over here and I can say total MOH, okay, at 3,500. And what I'm going to do is I'm actually going to come over here and I'm going to be kind of clever. I'm going to go equals total overhead. And then I'm going to go at, and then I'm going to cancel that. Sorry. I'm going to come over here. I'm going to go here. I'm going to say units like this. I'm going to go 3,500. And then I'm going to format that as with a comma. And now what I want to do is I'm going to go total, equals, and I'll go like this, total overhead. I'll go at, and then I put that under I2, which is right there. And I'll go and it always flakes out on me when I do this, units. Okay? So just like that, you can see it. And so what that does, right, is if I come over here and I expand that a little bit, if I change this to 3,600, and then it says, it's kind of clever, it says total overhead at 3,600. So I just use the cell reference in a formula like this to make it dynamic. Okay? So basically, I don't have 3,600 units over here, but I want to predict what the overhead cost would be. And so that's the point of regression within this context of analyzing the mixed cost. So we can come over here and we can say, we're going to do a formula. And so remember, total overhead cost in this case is going to be equal to our total variable cost plus our total fixed cost. So what would be our total variable cost at 3,600 units? Well, what do we know about variable cost per unit? It stays the same. So I can come over here and I can say my variable cost per unit times my units, which is my level of activity, plus, now what do we know about fixed costs as activity level changes? Well, fixed costs stay the same. So in that case, at 3,600 units, I would expect fixed costs to still be the same. So that would be my total overhead at 3,600 units. What about at 3,500 units? And then you can see it matches right over there. Okay. We can also do something called forecast. I'll say forecast function like that. And what I can do is I can go forecast. And then so this is a function that's going to give me the exact same answer. What's my x? It's my number of units that I want to forecast. And I'll say, there it is. What's my known y's? It's right over here. And then my known x's, right over here, like this. And there we go. And we get the same answer, and we can format it as currency. Okay. Now, I could have done some other things to make this a little bit more clever. So what I'm going to do is I'm going to just use some range names. So we've talked about this before. So I'm going to come over here and call this overhead. I'll come over here and call this units. Okay? So now what I'm going to do, and I'm going to call this units predict, like that. So now I've done some range names, and now I can be a little bit more clever. So I can come back and redo my forecast function like this. I known X, I click on this, units predicted. I known Y's, and see how it changes to OH, that's my range name. And then my known X's, right over there, units. And I'll get the same answer, but it's just nice because it's got all the range names. It makes things much, much easier to for somebody else to read and for you to come back and remember what you did. Okay. The last thing I want to do is just kind of show you quickly on how to do a little graph, kind of like what I did right over here, that little graph. I'm going to do something similar to that. Okay. So I can come over here, and I'll come over, I'll say insert, and I'm going to select these like this, and I'll say insert, and I'll click on that. Okay, and then what I can do is so that's all I did is I just clicked on the first one, I right click, and I can say add a trend line. Okay, and then what you can see when I say add a trend line, I can say display the R at the equation, and then the R squared. Okay, and then I have my basic graph just like that. Alright, so it displays the R squared. You can come over here if you want to and make it go backwards 50, like that. We'll tab over, and I'll say 500. And see, now it comes back to the intercept right over here. Okay, so that's going to conclude our lecture video here on regression in Excel. And regression in Excel is something you need to know how to do for your case that you'll submit to me. Okay, thank you.